to my best understanding. And I have already streaming in case they were testing it out.
Okay. Yep. I've already done some of it. Yeah, this is there were some things yesterday, like exceptions and things. There were some kind of missing things. And I would drill the classes and stuff a little bit more where you go. Yeah.
That's not my first thing.
Yeah. I mean, classes, interfaces, exceptions. I think unit tests would make sense like in the context of like, because until you've done interfaces, it's sort of hard to. Well,
No, it's not.
yeah, that's true.
Careful with that statement.
Yeah.
I don't believe in that one. I know what you're doing, but I don't believe in it.
Well, that's true. All right, so.
In badly designed software, you're correct.
Well, until.
And we had a class yesterday, no, we had adder.
Yeah.
You know how easy it's going to be with that.
That's true. Yeah.
There's a reason I'm doing things in this order. I don't want to talk about interfaces just yet.
Okay.
Probably by this afternoon.
Well, if you do unit tests just on like a simple thing of it, maybe towards like the last day, it can be like, okay, here's like
Oh yeah.
fuller unit test with mocks and like that.
Yeah,
kind of
I'm not
thing.
touching on mocks today.
Okay.
This would just be, we've created this cool class. We've had the F5
So
test.
when
How do
you
we
do
test
mocks
it?
and stuff,
With
you
that?
want to do some
I was gonna be
test
there
test. Okay.
with DI. But
Okay.
that's later next week.
Yeah. Yeah.
That could be overwhelming.
Yeah. Agreed.
Let me know when they're ready.
Yeah.
Okay?
I think give just like a minute or two, there's people still coming in.
Okay.
Okay.
All good? Good morning. So we left off yesterday with a few classes. All right, we created an adder class, then a name processor. We ended with a quick animal We made him bark. That was kind of fun. Then we all went home and slept. Let's pick up where we left off, and let me know if any of you have any questions. Because I know sometimes when I go to sleep and wake up the next morning, like I have new questions about what I talked about. Are there any questions related to those last things we left off with? Anything that came up that you were like, oh, I should have asked this today? Nothing. That's good. That should be a good sign. That should mean we remembered everything and it's all pretty clear. That's good. So I'm going to revisit a couple of the topics we talked about yesterday, because I think now that we've talked about how to create a class, we need to revisit a couple of those topics. I introduced them early in the day and said if they didn't click, we would come back to them, and now's the time I want to come back to them. So what I'm going to do, I'm going to create a new console app. We did that many times yesterday. I'm going to do that again, just to give us a nice clean playground, a little sandbox. And we're going to talk a little bit more about value types versus reference types. Now's a good time now that we've created one of our own classes. So let's add a new project. Remember, I'm right clicking on the solution, add new project. Let's do another console app. I'm just going to let mine auto number, so it'll be number 11. You can number yours whatever you wish. And I'll type just a little bit of code just so you remember where we were yesterday. You can follow along if you wish, but you've already seen what I'm about to type. If I have a variable and it's a Boolean and I initialize it to false, then I create a new variable and I set it equal to the first. Remember that these Booleans are value types, so I now actually have two different falses. They can be changed by themselves. And we call these value types. The reason we call them that is the variable actually stores the value itself. So once I create two of something, I have two different copies, and they actually hold that they're independent values, completely independent from each other. So here, obviously they'll both be false, and if I change value 2 to true, it of course is going to be true. The key thing to remember is value 1 remains false, because it's an independent value. Now we already talked about that yesterday. That's not new, but I wanted to sort of restart your brain on that, because now I'm going to add a class. And I would like you to follow along, because I think there's going to be some cool muscle memory here, and you'll be able to use breakpoints and see some kind of nifty stuff happen. This will be pretty simple. The class I'm about to add will be much simpler than what we did yesterday. I'm going to add a class that you'll sometimes hear in our industry people refer to these things called DTOs. I believe that stands for Data Transfer Object. It sounds like a big fancy term. All it really is a class with no behavior. It's a class just with public properties on it. We use these DTOs because if you think about it, obviously I can store an integer and I can store a date, but what if those two things are tightly coupled? So the date is a birth date and the integer is an age. Right? Those kind of deserve to be somehow bolted together and passed around as a single unit. Having two different variables is okay, but shouldn't they be wired together, like if they're supposed to be on some sort of person object? And the answer is yes. And we can use classes to do that. And we call these things DTOs because generally they're just data combiners. Think of them as a really complex type. Classes are not the only way to do it. I'll be talking about a different way to do it next week, but we're going to stick with classes right now so that we don't become overwhelmed. So let's add a new class. So we've got our new project. Let's add a new class. And I'm just going to call it person. This is going to store a representation of a person. So it puts the file in the folder, as we already know, and gives us the layout. You don't have to remove usings. Whenever you see me go to the top there and get rid of some, that's just my style. If I'm not going to use anything in that namespace, I get it off the screen. I just like to type a lot less code. You don't have to do that. It won't hurt if you leave them. So I'm going to make it public. I'm just getting you in the habit of access modifiers. I want you to be typing them even if you're not making a conscious decision to just yet. We'll get back next week to how to make really good decisions on that. So public class person, and let's give them a name. Now what I showed you yesterday, remember I made a couple things private read-only. Private because I didn't want anybody to see those things, read-only because they wouldn't change. I'm going to type something a little different here, and it's going to look a little bit different on the screen. Some things will be similar, some things will be different, and I'm going to compare and contrast the two. So I'm going to open up something from yesterday when I'm done here. But just type what I'm about to type, and then I'm going to talk about it. I'll do string name. Now that get and set is new to you. You haven't seen that yet. So just type it as is. So the beginning of this is what we call a property. All right, so it's actually, the even more correct term is it's an auto property. And I'll get to why it says auto in a minute, but it's a property. There's a lot of different opinions on fields and properties. The basic gist of it is this: if you're going to have something private and encapsulated inside of a class, we generally use fields. They are, as I said yesterday, kind of like class level variables. Properties are very similar. They're going to feel almost identical to you. They'll feel really identical today. They are actually, under the hood, they get turned into methods. They're very much like fields, but we generally expose them to be seen from outside. That's the general convention. I use the word convention on purpose. This is not really a technical limitation. The two constructs are very similar, but not identical. So yesterday you saw me do fields. So let me open up something where I had a field just so we can compare and contrast. Let's find that adder class. See, it still has an access modifier, but I had private yesterday. I had read-only just because I knew I wasn't going to change it. They both have types. That's normal. Both have names. You'll notice I capitalized the property. That's by convention. It's not a technical limitation, but you're going to see developers do that. But you don't see the get and set here. Like, they're not actually there as properties. Fields and properties are almost identical, and probably for most of this course you're going to have trouble differentiating the two, because I'm not going to get into the really advanced stuff about why one might be better than the other. So I'm just going to say, generally speaking, when you're going to make it private and only visible inside the class, generally use a field, as I'm doing here. When it's going to be public and sort of exposed, and people who are using the class can directly see, access, maybe even change the value, we generally use properties. And there's a bunch of reasons for that I don't think I feel like covering right now. That's just one of those things that we'll just get in the habit of, and maybe later on next week I'll get into more depth about why developers make that choice. Because it is a little more technical than I really care to talk about. And it doesn't affect what we're trying to do right now. So we have this person class. We've got a name on it. Let's put something else on, because if it only has a name, that doesn't really make it special. We'll go ahead and put, I'll put age. Age is a nice simple integer. I'll do the same thing, the get and the set. So, similar to a field, it does have an access modifier, but I've made it public. You all have already seen data types. Remember, this is statically typed language, so we're always going to be specifying types. Most of the lines in C# are all about types. We're talking about what the type is, what it should be, what it can be, that sort of thing. We give it a name, so that property should have a name. This is what the caller will see when they hit dot, like it's the actual name of the property. That's kind of, but you'll see that in a moment. We'll go back to program.cs in a moment. We'll look at that. So this get and set, what is this doing? Well, this is a shorthand in C#, and I will show you the longhand, a more detailed version later. But this is a shorthand that we generally call auto properties. What we're basically saying with that curly brace get : set : is everybody can get this value and everybody can set it. So it's a fully publicly exposed. Anyone outside this class can modify it. It's just available for everybody. And this is a shorthand. When I show you the longhand way to do properties later on, you'll see why you'll probably prefer this one if you don't need other data. Question in the back?
So can you use get and set to expand the scope of, I guess, that class right there?
The question is, can I use get and set to expand the class? You mean up here?
Well, you said that anything can edit it, right?
Mm-hmm.
So does that mean any of your classes outside of that class can also edit it, or is it?
Yes. And in just a moment, I'm going to jump to program.cs, and we're going to see it touching those properties, and I think you'll see. If I haven't answered your question by then, ask it again. How about that? We're getting really close. We're moments away. So we're just saying get and set. So now we have two properties. I'm not going to put any methods on this class. This is a simple DTO, data transfer object. Once again, it's kind of just a way to squeeze two variables into one type and then pass them around a little bit throughout other parts of the code. So that's all I want to put in person. That is the entirety of my person DTO class. So let's get back to program.cs. So if you remember yesterday, we can instantiate a class. How do we get an instance of that person class? What keyword do I need to type? New. That's right. So I'll have person1 equals new person. Now I did not put a constructor on, so I can just instantiate it with an empty constructor. I'm going to remove this value stuff. That was just a warm-up to remind you what we talked about the other day. So new person, person1. I'm going to go ahead and create a second person. Let's go ahead and just do that right now. Now I'm going to put a breakpoint here because I want to use the, I want to go into debug mode. Make sure to set your app to set as startup because I want it to run the correct one. So how many people are we going to be creating in RAM when this runs? Two. That's it. Yep. Both of them are going to be initialized and have default values for their name and age properties. What will those values be?
Null.
Null for what?
The name.
Null for name. What about age?
0.
0. That's right. It's exactly right. So good job. What you're remembering from yesterday is integers are value types, so they're never null. So it's going to be set to some what I call a reasonable value that was chosen by the .NET peeps. And 0 is a fine value to start with when you're dealing with numbers. And name is null because it's a special primitive reference type. So we can run our code and we'll double check to make sure we were correct. Notice I'm using a breakpoint. I'm not using the right line. The breakpoints are easier to check for nulls. It can be tough to write a null. It doesn't really make sense to write a null. This is the first time I'm running this today, so it'll be a little slow on the first one. There we go. Alright, it'll hit our breakpoint. And if you're using the locals window, which, like I said, if it's not up, I think it's in debug, Windows, locals. That saves me from having to mouse over the variables. If I expand person1, I see 0 for the age, null for the name, and person2, 0 for the age, null for the name. And do remember that these are two different places in memory. Those are two different ages, two different names. I bolt the age and name together, but the two names are in no way related. I have two completely isolated pieces of data in memory. All right? So we've inspected the code. We've inspected the data. It looks good. Let's go ahead and give them some reasonable properties. And now, Brendan, this is what I was talking about. We would actually see possibly an answer to your question. If we do person1 dot, and we look at this list, remember there's always 4 things on this list that we're going to ignore forever for the remainder of this course. Equals get _ get type into string, ignore it. But you see we have 2 other things with different icons, age and name. Because they are public properties, we can set them. So person1 name is Bob. I can also set his age. Well, not a string. We'll make him 30. All right. And let's do the same thing for person2. We'll set a different name and different age. 25. Once you get that typed, or something close to it, you don't have to use the identical values I'm using. There's nothing special about the values I'm using. It's just demonstration data. I'm going to run this. And of course, we'll look at the locals window. We'll take a glance at it. We'll see that we have 2 isolated sets of data. I'm going to use the locals window again, expand it. Bob is 30, Alice is 25. 2 different variables pointing at 2 different places in RAM, 2 different class instances, 2 different sets of data. That's probably not a surprise to you, but let's do something that you might not have expected. Let's do person3 equals person2. And ask yourself, if I run this, what will the values in person3 look like?
Alice and 25.
Alice 25. I heard multiple people say it, so good job. Let's double check. Let's see if you're right. I think you're going to be right. Look at our locals window. We'll check out person3. Yep, exact same thing as person2. They are both Alice and both 25. Now I'm going to see if I can trick you. So be ready to be tricked. Or be sensitive to that. If I do person3.age equals 27, and I run this, what will person3's age be?
27.
Good guess. what will person 2's age be? I'm hearing a lot of 25, so let's run it. So we'll do person 3 first. 27, good job. Person 2 is 27. Now that's different, right? That first thing I showed you yesterday when we were, I had two Boolean values and I set one and didn't touch the other. Those are value types, right? So they have isolated data. The two variables actually point to two different values. Classes are reference types. And I can redraw that image that I had yesterday real quick if you want. The point to remember here is this line 19 did not create, it had a new variable. A new variable got created named person 3. That's true. And the type of that variable was person. But it pointed at the same reference as person 2. So there was only, there still remains, this whole code has two people in memory, and when line 19 runs, it remains 2. In which case there is one variable pointed at the first person, person 1 is pointed at the original person, but now there are two variables pointed at a single shared object. That's why we call them reference types, because those two variables are referencing a single same entity. So when you change it from one variable, they're both seeing the change. Brendan, did you have a question for a moment there? Okay. So let me I'll have to redraw that image, but let me redraw it just to sort of get us back to where we were yesterday. Sometimes the image helps people, sometimes it does not. So remember we have this stack, it's got lots of entries in it. And I'm actually going to try to mimic what we actually have. Heap is always this big circle, big old vat of data. So if we look at our code, we have we end up having 3 variables and 2 people. All right. So we do have 3 variables, which is what my blues are going to represent. But there are only 2 people. And I'll draw how how I envision these lines sort of connect. So the person 1, so those 3 blue squiggles, that's person 1, person 2, person 3. Those are the 3 different variables. So person 1 points to Bob, and that's fine. When I created that second variable, person 2, that pointed to Alice. That was not a surprise to everybody. We looked at the data and it was pretty much what you all predicted. What tripped you up is when we created person 3 and set it equal to person 2, what we were saying is, please point at the same reference in RAM. So this third variable points at the exact same blue dot. There is no third object, there's no third person that was created on the heap. That big circle's the heap on the right side there. Okay, so we have 2 variables and they can both touch this. And I believe if you have an object in JavaScript, you set 2 variables, it's referencing, isn't it?
I think so.
I think so. So there is a little similarity there, not in how all this works, but having reference variables is not unique to C#. I think it even works that way if you actually have an actual object in JavaScript. It's actually very similar. This can trip people up though. So it's not a surprise, and you should not feel bad at all if you guessed that the value would be 25 for person 2. The key here, and I have it on the screen again, when we did person3.age, we were just accessing that shared object. So when we set the age to 27, both variables see the change. Question?
Yeah, we've got a question once Salem about value types. I think there's some confusion on that as to what value types are. And I'm thinking that since you're showing reference types there, you do kind of the same thing for value types and shows that it actually copies it's actually like a copy of the value in that example. It might help them because they're still struggling with value types a little bit.
Okay. From what you can tell from the chat, do you think integers would be sufficient, or do we need something complex?
I think so,
okay.
Yeah.
So I'll use a comment here to sort of draw a line just visually on the screen. I'm going to shrink the code up just a little bit so we can get more on the screen. So let's do some integers again, similar to what we did yesterday. So I'll do value 1 equals 10. Oops. Let me make sure I mimic this. We'll do a 20. I can set those. Okay. That should be a pretty good mimicking what I'm doing up there.
So then, like, what is value 2 going to be? Exactly.
Yeah.
Yeah.
Yeah. So obviously, value 1 is initialized. These are integers, so we're back to value types, right? So this is we're going to compare and contrast these two ideas. So we're back to integers. So value 1 is set to 10. I actually never change it, so that'll always be 10. That's not really a surprise. I create a new integer, value 2 equal to 20. That's obviously going to sit by itself, just like person 2 initially sat by itself. But when I set value 3 equal to value 2, this is different. So lines 15 and 21 operate much differently. They're typed very similarly, but they operate much differently. In this particular case, I would ask the question to you, obviously when line 21 runs, value 3 is also 20. But what I want you to remember is with value types, it's two different 20s. Okay, they're totally isolated. There's no heap sharing on that part. So when I set value 3 equal to 5,000, if I ask you what is value 3 going to be, you'll probably guess that correctly, 5,000. But the real thing to ask is what is value 2 going to be?
Still 20.
Still 20, because they are not connected. Value types, when I adjust them, I'm adjusting just that one. It kind of has a limited scope of just itself. It can't see.
So you could say, like, the value is actually stored in that variable, not a reference to the object.
Yes, Harper's making a great point. One way to think of it is the actual value is stored in the variable with value types. But with references, it doesn't store the person, it stores a pointer to the person. And it's just two different people pointing at one, or two different things pointing at one person, so they both can, with reference types, they're sharing that same reference. Do I have a question?
What is a pointer?
So I don't want to get too deep. And the reason I don't want to get too deep is although pointers actually exist in C# and they're a real thing, and if you come from the world of old school C languages, like C itself, talks a lot about pointers. I'm using that as sort of a generic, almost Merriam-Webster's dictionary interpretation, a non-technical interpretation of the word. I'm going to go back to this drawing and say that, remember this is my reference types again. Person 2 and person 3 point at the same person, Alice. So I'm using a Merriam-Webster's dictionary. I know at least one person here in the Richmond room has done some work in C. I'm not using that word. Although there's some overlap there, I don't want to get into that in this class. It's inappropriate. C# is what I refer to as a high-level language. We don't really get into those depths. The deepest we get into this pointer-like understanding of how computers work in a language like this is exactly what I'm showing you right now. As long as you realize that reference types, whenever you have a variable that's of a reference type, they're pointing across this C into a C of across the C into a world of heap storage and RAM, and that they can all point at the same object. And this is going to be common. So even if it doesn't click for you now, I'm going to keep harping on it throughout the course. I'll keep touching on the topic because it's really important. It's super important. And you can kind of guess why it's so important. Many of you guessed that person 2's age would remain 25, and that was incorrect. That was a great assumption, because everything I'd shown you up to now had showed you that would be true. But that's why we're talking about reference types like this yesterday afternoon and this morning. So when you compare these two, we'll run it. So I ran it before when I did the reference type. So let's run this and use our locals window and verify everything I said was correct. Value 1 was, of course, initialized to 10. That's a value type. That stayed 10, no big change. Value 2 was initialized to 20. That's not a surprise. I set value 3 equal to value 2. I want you to think of it as it made a copy of the value. That's how value types work. So value 3 got a new version of 20. So on that line 23, when I set value 3 equal to 5,000, it didn't touch the original. It had its own 20, and then that 20 was overwritten by a 5,000. But the other 20 remained completely untouched. That's in complete contrast to the reference type, which I'll open person 3 and person 2. When I changed person 3's age, see if I can get it all on the screen here, to 27, it also changed the other one. And that's because that line 15, which I'll highlight, when I said person 3 equals person 2, it did not make a copy of the person. That's what value types do. Value types make copies. It did not make a copy of the actual person. Instead, it just said, I'll point at the same one. Question?
Is that because it's still just a variable?
I'm not sure how to answer that question. Could you elaborate just a little bit?
Alright, so right now as it sits, it's just a variable person 3.
Yes.
Right, so you're just changing the variable, essentially, of both, right? But if you were to like write out person 3 before you did this, would it still change person 2 because it's not a variable anymore?
So line 15 is creating person 3. So I could not write anything out before line 15. Or did you mean after line 15?
Right, so if you were to like actually commit something, like now person
Like how you
3
get
is
the
a
new person up top of person 1, person 2, right now.
I'm not sure I get the question.
So I think, let me, Greg, I think it's, what you're saying is because you're setting person 3 to person 2 and not newing it up first, not instantiating it first, it basically is, instead of creating a copy of it, instead of creating a copy of person 2 and having its own data, it's pointing at person 2. So it's pointing at, person 2 gets made, and when person 3 gets made, it just says, hey, point at person 2.
right.
Like it's pointing at the same spot in memory. It's pointing at the same actual person. So that if person 2's name or age changed, person 3 is pointing at the thing that just changed versus having like a copy of that data. Whereas the value types below are like 10 and 20. When you set value 3 to value 2, you're setting the initial value. You're copying that 20 in there, but then you can independently change those two things. They're sort of separated. The values are separated. With reference types, it literally is just a reference to the other thing. So when Derek is setting person,
Harper, I want to remind you, they can't hear you. I can't repeat all that.
Okay.
If you're going to talk a little bit, could you get closer to the mic? I don't want to have to repeat all that.
Yeah, that's a good point. Sorry.
If you want, just so they can hear you, because
Yeah.
I can't remember all that.
Yeah, sorry. So the question was, we had a question about reference types on line 15, where person 3 gets set to person 2, and I guess the on line 9 and 10, you're kind of newing up, you're instantiating that object, right? So person 1 and person 2 are newing up a person class, so they are an object at that point. That's an instantiation of that class. So those have their own empty things. Then they're kind of getting filled up with data in lines 11 through 14. Then on 15, person 3 is essentially, that variable is pointing to the same object that got newed up that's in person 2. And that's why when person 3 age gets set to 27, person 2 also changes, because they're both pointing at the same thing. Inside the computer's memory, there's an object, there's a person object. Person 2 variable is pointing there, and person 3 variable is pointing there. They're both variables, they're pointing at the same thing. Down below with value types, on line 22, value 1 is 10, value 2 is 20. On line 24, when you're setting 3 to 2, you're copying that value. You're copying that 20 in there and setting it as an initial value. You can change value 2 and value 3 independently from there on out. They're two separate things. They're two separate values in memory. The variables are different.
Okay, so my question was really more that because you said person 1 equals new person, at that point, does that mean that the name and the age are just null?
Yes.
At that moment?
Yes.
Right, so person 1 is just null, null. Person 2 is null, null. Person 3...
Zero. The age would be 0, yeah.
Yeah, okay,
Yep.
but person 3 doesn't have a box yet.
Right.
Person 3 doesn't
So if there was
exist.
a person 3 box, essentially, would pointing at person 2 and then changing the age right there do the same thing? Is it still going to affect person 2 at
Like
all?
if you newed up a person 3,
Right.
and then set it to person 2?
Right.
No, because you're redefining, it's pointing at the,
So
it has
okay,
its
so-
own reference, then you're redefining it to point at person 2 reference, yeah.
The terminology is what I was tripping up on.
So here,
So right at this moment, person 3 is just a variable. It's not.
It's just pointing at person 2, yeah. It's pointing at the same thing.
It's not tangible
It
All
is,
right.
it is tangible in that it's pointing to person 2, and the values there in person 2, it's pointing there.
yet. Well, I guess my main question is if you were trying to avoid this, would you just go ahead and instantiate person 3 and then set it to person 2 and then tweak the age?
that would have the same effect. What would happen there is you would create a third one. So the question, just for everybody in Winston-Salem, he's asking, what if I had instantiated person 3 to a new person and then assigned person 3 equal to person 2? So I'm going to answer that. When you did that initial line of person 3 equals a new person, a third one gets created on the heap. You have 3 independent variables, each pointing at their own instance. If I then set person 3 equal to person 2, it ends up in the same state it is now, where person 2 and 3 both point at the same person, which is Alice, and that other one in RAM actually gets what we call garbage collected. The memory gets deleted, emptied out.
Right, so if you change person 3 age to 27, would it still affect Alice's?
After the reassignment to 2, yes. Before the reassignment to 2, no.
That was my question. Okay,
Gotcha.
thank you.
Great. So that's actually, that's kind of the next step in complexity. So what I'd like to do, just to, so you don't have to trust us, let me tweak this code a little bit. This is a great conversation. I'm going to first improve the variable names, just in case that's throwing people off. So there is a hotkey for this. It's F2. Oops. I didn't mean to make that all caps, so I'm going to do this twice. So I'm going to make sure we get real names in here. Person 3, let's rename that to another Alice. That may or may not help. And to your point, I will go ahead and I'm going to mimic what you just said. Okay. So we need a new name. We'll do Charlie equals new person. Let me give Charlie a name. Let's give Charlie an age, just to be complete with our example. We'll get rid of this non-compiling line. I'll just use a breakpoint down here. And I'm actually going to walk through this code slowly with the locals window open. I think that might be beneficial. And just to mimic what you said, now these variable names will be really bad. But if I did say Charlie equals Alice, this will work. And then we'll see what happens. I'll do Charlie.age equals something. I'll do something dramatic. So we're going to walk through this code one line at a time. The Bob and Alice variable names are good. The Charlie variable name will be good and then will become really bad. So ignore the value. So we have, make sure I can show you. So we're before the first line executes. You'll notice that Bob, Alice, and Charlie, as far as the locals window is aware, I don't want you to think of it like this, but it knows that it's going to encounter those 3 variable names and they're effectively null. The reality of it is they don't actually exist yet. That's the actual reality. But it shows it as null. So just sort of imagine that they're nothing right now. They don't actually exist. And we'll do one line at a time. Boom. Notice what changed right here in the locals window. Bob suddenly went from null to a person. But notice his values. His values are the initialized values. His name is null and his age is 0. I'm going to advance one more line. Alice is now a person. She has default values. I'm now going to set Bob's name and age. So we set his name. You see how it turns red? This is kind of cool about that locals window. It alerts you to things that you were trying to look at and change. So Bob's name went from null to Bob. That's good. Now his age will probably turn red next. 0 to 30. Boom. Not really much of a surprise. So let's do the same thing with Alice. So Alice's name is null. Now it's Alice. We're setting her up correctly. Her age is 0. Now it's 25. Now we're good. Now we're going to get sort of to the example you were asking about. Charlie is a brand new person. So there's another, every time you see the new keyword, almost always in C#, so I'm just going to say always for this group. Whenever you see that, just know there's another thing appearing on the heap. That always means there's a new object. Regardless of what you're doing with the variable, boom, a third thing exists. There's now, at this moment here, Charlie exists. You can see he went from null to an actual person. I'm going to expand him. He has default values, just like the other two. All right, this should be very repetitive for you now. We're going to give him a name. Boom, and now he's a name. We're going to give him an age. Goes from 0 to 55. Now is the tricky part. So we have 3 different variables, Bob, Alice, Charlie, pointing to 3 different items on the heap. 3 different references out there. 3 different objects. 3 instances. You can use all those terms as synonyms. Whatever word helps you remember this will work. So I set Charlie to Alice. You got to watch. You got to watch real close. Watch that bottom part for Alice and Charlie. Boom. The actual Charlie variable is now, its pointer has changed to the actual Alice in memory. So although the variable is named Charlie, because that's who he originally was, Charlie and Alice are now both pointing to Alice.
Yep, right.
Now your question, of course, you might ask is, well, what happened to Charlie? Poor Charlie's gone. Charlie is no longer accessible. He's technically still in RAM, but the .NET Framework is going to delete him within milliseconds, minutes, at some point. We actually have no control over that. It's called garbage collection. We'll talk about that later next week. But Charlie is actually completely gone. Charlie, the object, is gone. I still have a variable named Charlie, but variable names are just variable names. I could have named that X or person 3, just like I had it before. So Charlie and Alice variables are both pointing at the single Alice instance. You'll notice his values both went red because they're actually both Alice. And now, I will get to your question in just a moment, Brennan. I do want to advance this one line, and I'm going to change charlie.age. Because both Charlie variable and Alice variable point to Alice, because she's actually the only thing that exists now. There is no real Charlie. You're going to see the age change for both. Both 25s go to 88, because they are the exact same thing in RAM. They're not a copy. There's no magic happening here. Don't think of it as 2 different objects in RAM and it's copying them around and magic stuff is happening. No, it's much simpler than that. It's literally 2 things pointing at you. So if your birthday occurs and you age by a year and 2 people are pointing at you, they both see your age increment because there's only one real Alice in this world. Question, Brennan?
Is there a particular time in the real world where we would be doing this as a developer, or is this something which we would probably try to avoid?
So the only thing I've done on the screen, so the question is, do we do this in the real world? Is this something we might want to avoid? The only thing I've done on the screen here that's not good is the fact that the Charlie variable is named Charlie when it actually points to Alice. That's confusing. So the naming of the variable here is subpar. However, conceptually, what I'm doing here, you're going to be doing all the time in C#. Whether you're consciously thinking about it or not, this is its reality. And there's no way to escape this reality. If you're using classes, they are reference types. And what you're going to find as we go forward in the course, we're going to have methods that take in parameters that are reference types. And it's going to be super critical to understand that if you modify that variable, you're also modifying what the outside world thinks of that instance. So my real sort of even more global aggressive answer is you're doing this all the time, whether you like it or not. It's kind of how the language works, which is why it's such an important thing to get to. What's a value type, what's a reference type is so important to grasp. It might not click for you immediately. That's okay. That doesn't mean that you can't proceed forth in the course. But we're going to be doing this stuff a lot. This is all being done in one method. But when we start going to multiple methods, and we're going to have lots of different variables and arguments to methods, and they're all pointing at the same instance, you're going to want to remember that when it comes to a class, you might have 20,000 variables, all of them pointing to a single instance. And if one of those increments the age, all 20,000 see the change. And that's normal in C#. It's common, very common, all the time. Let me pull this locals back up a little bit. Yeah, so the only thing I've done bad here is the Charlie named variable has a bad name now, because Charlie's actually gone. The real Charlie, the object that contained the string Charlie, and his original age of 55 is no longer accessible. You cannot get it back. It's gone. That RAM was allocated and then released. Other questions? Do please ask them. I mean, this is super important. If it hasn't clicked, we can go through these examples. I'm willing to spend time on this, because if it doesn't click, okay, yeah,
so
go
like,
ahead.
is the information from program, like from the program and the class stored differently, like we're talking about with the different, like the RAMs? Like, is it stored differently in different places?
Do you mean value types versus reference types?
Yeah.
Gotcha. So the question is, are they stored differently, the different value types versus reference types? Let me get my little ugly drawn image up, and then I will answer that question. So let me put something else on this image to help me clarify. I'm going to use some orange or something. I'm just going to draw something here. We're going to pretend that that's an integer. Orange is an integer. The blues are still reference type. So orange is value type, blue is reference type. This is 4 variables. You can imagine this is a visualization of having 4 variables in scope in that main method. 3 of which are pointing at reference types, 1 of which is an integer. You'll notice that they are all, as we would say if we were calling a method, on the stack. All those variables they really exist. They're not some magic that's abstracted away from you. There is really a small piece of RAM on the stack allotted to the Bob variable. And its size depends on the operating system, but we'll say it's always 64-bit. It's a little thing that just contains a pointer to Bob. Alice contains pointer to Alice. Our Charlie variable actually also points to Alice, which this image still accurately shows. The 4th variable there would be some integer, which I don't have, but we'll pretend it's like that value 1 I had. Value 1 equals 10. You can pretend that orange one is value 1. It's a real variable, but in its actual 64 bits of data is the value of bit alignment that equals the value of 10. So it actually stores that. So I know it's sort of a technical answer, but to get an answer to your question, both reference types and value types have something on the left, and they always allot a little bit of RAM. The true difference is in the case of value types, the orange stores the actual value. So it stores enough data to store the number 10. But with the case of Bob, Alice, and Charlie variables, they store only enough information to point to much larger pieces of information on the heap. Both are stored in RAM technically, but I want you to visualize it as 2 different places. Technically, it's all in RAM, right? It's a computer. It's all stored in RAM. There's no magic RAM. But I want you to visualize them sort of this way, hopefully with a better drawing. But something like this, where there are 2. So there's some overlap. So to answer your question, there's overlap. When it comes to this, yeah, they're the same. When it comes to the stack, they both take up space on the stack. But only reference types take up space in the heap. And I will talk about boxing next week. Other questions about this? Show of hands just here in Richmond. Would you like to continue to see more examples of this? If so, raise your hand. Otherwise, I might move on a little bit to a new topic. But raise your hand if you want to see more of this, if it hasn't clicked to the point where you're comfortable moving on. Okay, got a few hands.
I'm asking.
You're asking there?
Yeah.
Okay.
It
Yeah, we
takes
have
a
a few
second.
hands here. Let's see. Is there any particular aspect of the code on the screen that you could tell me is the most confusing? Or is it something like this line 20 is still just not clicked what it's doing? If you could give me a hint. If not, I'll try to make up a solution. Let me try that. Let's simplify this a little bit. I'm going to, people are probably going to want to see this code. So let me comment out some of it and push it off screen. I don't want to delete it because we may be uploading some of this later tonight for all of you to peruse over the weekend. So I've commented out all the code below here that matters, right? This is all commented, so now it's off out of your brain. So now we just have Bob and Alice. We have two variables. Each one of them points at an independent person. That's pretty basic. I'm actually going to go back to naming these like this. I don't know if what I'm about to do will help, but there's more examples. Hopefully will help. I'm going to deliberately go a little bit overboard here, to sort of see if I can prove a point or make something sink in a little bit. Now check out that code. So the whole Bob and Alice thing is probably not much of a surprise to you, but I do have a whole lot of persons, all of them pointing at Bob, right? And let me put a breakpoint so I can run this. Actually, I should put the breakpoint higher. Otherwise, oh well, it'll work. Let me get enough on the screen here. So how many times do we see the word new on the screen? Twice. That's correct. So how many object instances are on the heap, as we say? And remember, the heap is the part on the right here.
Is it 2?
2. That's correct. It's 2. It's 2 throughout the remainder of this code. Remember, my breakpoint is actually off the screen to the bottom, so 100% of this code has already been executed. All of it's been fully executed. There's no magic off the screen here at the bottom. So you can sort of think of it as count the number of times you see the word new, and that's how many objects are on the heap. However, how many variables are there in play? I heard the word 5. 7. 7's what we want. Yep. 7 because we have a Bob. So the cheat here is count how many vars there are. 1, 2, 3, 4, 5, and then there's 2 at the top, for a total of 7. There's a Bob, an Alice, and then 5 persons. So there are 2 things on the heap, and there are actually 7 variables on the stack. And I'm going to use the word stack loosely here. Later on in your career, you'll learn that I'm slightly not correct when I say that. But let's just forgive me for that one. So you got 7 total variables in scope. Let me ask you this. How many variables point at the Alice object in RAM in the heap? Okay, I'm hearing some ones. Any other thoughts? Does anybody else want to participate? I'm hearing the same voices. Shaky. Just one? Yeah, just one. Yeah, that's exactly right. There's only one. And you know that because obviously, I want you to look at that line I have highlighted. What might be confusing a little bit is that that's a pretty actually complex line. There are 2 major events occurring. The first event that occurs is on the right side. The new person object gets instantiated and put on the heap. The other thing that's happening is the Alice variable gets created and put on the stack and points at that. So it's actually 2 things happening. So that might be making the confusion a little bit rougher. Those lines are doing 2 things, and they're 2 important things. Creating an object on the heap is sometimes a large operation. In this case, it's just a name and an age. But there are classes in real projects right now in the world where they'll have hundreds of properties. I mean, they're huge, massive things. They might even connect to a database and load up some RAM, load up the RAM with some image data or binary data or PDF stuff. They can actually be huge objects. And so it might be 500 megabyte class. I hope it's not. I would consider that bad design potentially, but it could be a huge class, and that gets instantiated. Then a very tiny variable named Alice gets created, put on a stack, and points at it. So both of these lines do 2 things. They're doing them in a particular order, but from your point of view as a developer, it's kind of one action. It's sort of a compound 2-step phase action. So when we do this line Alice, it creates Alice in RAM, and only that variable is set to that. Nowhere else below here do we say something equals Alice. So when I ask the question, how many variables are pointed at Alice? Out of the 7 total, how many are pointing at her? The answer is 1. Very simple. And of course, I'm going to ask the other question that you can probably predict. How many variables of the 7 are pointed at Bob? 6. Now you could have cheated there and said 7 minus 1 is 6, but that actually works. You know that there's 6. Obviously the first one, remember this first line, creates Bob on the heap, the actual Bob with it starts off with a null name. We eventually fill that in, but we create the null version, his initialized version, and we put Bob on the stack and point. So that first one works, and then we have 5 other variables that I created just on a whim, just to sort of show you this example, and all 5 of them point at Bob. And we can confirm that. So if we go down here, we'll look at Alice. Alice obviously is pointed at Alice. You can tell because her values are very Alice-like. There's her name, Alice, with her age. We expand Bob. He's very Bob-like. There's his Bob name with his original Bob age. And if we expand each person one at a time, 30 Bob, 30 Bob, 30 Bob, 30 Bob, and 30 Bob. So you were correct. There's only one Alice. There's only one Bob, but there are 6 variables that point to him, which means, and I'm going to stop this code, I can do anything with any of those 6 variables to change his values. Whoops. If I type it correctly. I can change his name. I'll make it Bobby, that way it's not too confusing. I'm using the person1 variable to change his name. But you know what I'm going to do? I'm going to use the 4th variable to change his age. What was his original age? 30. I'll even do that. Remember we looked at that the other day. The plus plus allows us to increment a number in place. So I'm using 2 different variables, neither of which are named Bob, to adjust the Bob properties. Let's run it. Actually, I'm going to put a new breakpoint in, so I'm going to stop this and rerun it. Give me a moment. I've confused Visual Studio. I stopped it right when it was trying to attach the debugger, so there it goes. Ooh. So I put in extra breakpoints so we can see the world change slowly. And feel free, when you're learning, C# when you have this powerful IDE, feel free to do this often. This is a very good thing to do to help you learn what's happening step by step as the code runs. Very, very good stuff. So if we expand Bob, he's still Bob 30, and I'm going to expand all the persons. They won't all fit on the screen, but I am going to expand all of them. I'll be scrolling it up and down. I hope you don't get seasick on me. So I have person1.name. Well, person1 points to who? Bob. So when I press play and we advance 1 line, we'll see Bob's name, Bob, change to Bobby. We're also going to see person1 name change from Bob to Bobby. You can see all of them became red. All of them became Bobby. They're all the same thing. All 6 of those variables, including all of these person1 through 5s, pointing at the same one. Same thing with age. I'm going to increment the age when I press play here. Now the code jumped, so I'm going to scroll up so it's not confusing. You'll notice every age incremented. And you just got to trust me, there are not 6 Bobs in RAM. There are 6 variables pointing at 1 Bob. And they're all tweaking him at the same, not at the same time, but in order of the code as it executes. Was that more helpful? Less helpful? Sometimes I like to do this. Whenever I'm trying to learn something, I'll go to sort of an extreme. And going to an extreme can sort of tease out something. Here it's kind of extreme to create 5 variables in a row, all with rather boring, tedious names, and assign them to the same object. But that allows me to have person1.name, person4.age, and let you see that doesn't matter how many variables are in play, they're all pointed at the same reference, the same object. This is just a bunch, this is 6 different things pointing at 1 Bob. Were there any questions from Winston about additional follow-up on that? Okay. Now, it might not have become native yet. You might just be having to trust me, but as we start tinkering with the code more in future exercises, we'll be making more and more custom classes, and you'll be able to sort of experiment with this and see stuff change. I think that's probably good for those examples. Harper, I do not have an exercise because this is mostly a review from value versus reference type. However, the next topic is testing, and it's going to be a long one. So I know it's a little bit early, but is a break maybe in store for, especially for Winston?
Yeah.
Let's take just a break, no exercise, just a 10-minute break. So it's 9:30. Let's resume at 9:40. A bio break, because the next part's going to be kind of long, and I will stop the stream since there's no exercise.